Hey guys, Mr. Riz here to help you out on the second part of our parent function notes here, and we're going to be looking at transformations. Now, this is going to be a longer video, even though we'll spend a couple days doing this in class. It's just kind of easier if we talk about all the different types of transformations, kind of throughout every single type of function. So, we're going to kind of see here everything all at once. So this is a longer video. If you ever need to kind of pause the video, skip ahead, do what you need to do, go ahead and do that. What I'm also going to be doing here is having Desmos off to the side. That way we can kind of really see, change the numbers real quickly, add a couple extra functions so we can see the difference here. All right, so just kind of recap a little bit before we get started into, transformations here. Remember that a parent function is the simplest form of a function. Okay. And let's just make sure we got this. Like a linear function is just like y equals x. Okay, that's a straight diagonal function, diagonal line. Absolute value is y equals absolute value of x. Okay, so maybe if we need to do like go through, okay, linear function is a straight diagonal line. Absolute value is a v shape. A cubic function is y equals x cubed. You guys remember that kind of looked at that graph. Our square root is y equals square root of x, and that looks like, that's not really that good of a line. There we go, like a half of a sideways parabola. And then exponential is y equals a to the x power. Now that one looked like that. Now there's different numbers we can have. All right, so next, oh, can't really see what that says here. Can I change the zoom? I'm just going to look at my printed off copy here. So each function in a family is basically, if we think about it, is just a version or a translation or transformation of the parent function. So that means basically any type, as long as we know what the parent function is, we can make any version of it. As long as it follows the same shape, it will go through. I forgot there's also quadratic on here. Okay, so let's look at our guide here. I'm going to try, zoom this in, or, I'm going to do this. It's clear on my drawings here. I'm going to kind of see if I can make Desmos a little bit smaller. There we go. Got these in here. Okay, so let's start with the parent function. I think the square root of x is an easy one to deal with. So if I did y equals square root of x, here's the keyboard, there it is. Okay, so we know the square root of x looks like so. So let's talk about what kind of translation happens when we add an h number inside of the square root. So if we have y equals, might be easier to just copy paste this here. Control C, Control V. If we put numbers inside, so y equals plus 5, or what if we do that again, but add plus 2? Okay, you can see what that does is it's still the same shape. Everything just gets moved to the left. All right, so we can say that this shifts left. Okay, what if we subtract? Okay, so what if we go through and change this to a -5, okay, -2, same thing, but now it's the same graph, but over to the right. Okay, so if we add a number inside of a function, that goes to the left. If we subtract, it goes to the right. And you can see it does the same thing here with any type of function. We have y equals x squared. Now inside the function would be like a x plus 5 squared. Okay, you can see it's the same graph, just moved over to the left 5. Okay, so inside, same thing. Do some Control Z. Let's go back to the square root. All right, let's talk about what if we added numbers outside of the function. So that means we're going to go outside of the square root here. All right, if I did plus 3 plus 8, okay, it's the same graph, just shifted up. Okay, so translations are pretty easy. Shift up, and then we can probably guess here what's the last thing that we can go on here. If we subtract these numbers, make a minus, it's the same thing, but everything is down. So that's shift down. Mm. Okay. So translation. So we're just moving, shifting the graph. If it's inside, it's kind of opposite of what we're thinking. Plus goes to the left, minus goes to the right. All right. If we are adding on the outside of the function, it would go up. We add, subtract, it goes down. Okay. Next, dilations. Dilations here. Okay. We can still do that. There's going to be a couple different ways we can look at dilations. But let's look first off. If a is greater than 1, there is a catch to this one. It should also be greater than 0, but let's talk about that. So if we have, now that's just outside the function here. We take the function and we times it by a number bigger than 1. All right, so if I do 5, I can do 2 here. What we're doing here is this is a vertical stretch. Okay, so anytime we multiply by a number bigger than 1 to the function, we're going to stretch it vertically. You can even see like something, let me try to do, what would be a good example? I can do a quadratic, so y equals x squared, regular parabola, look right in the middle. Now if I stretch that 2x squared, it stretches it by 2. So sometimes a vertical stretch is going to look very similar to a horizontal shrink. And that's because some of the functions we can write it in different ways. You know, I could stretch it even more, make it 6x squared. Okay, now it's even stretched even more. You're pulling the pieces up higher and higher off the x-axis. Okay, let's go back to square root. Yeah, we'll do square root here. Control Z's. All right, what if we have a number less than 1? Okay, we're still going to keep them positive, but let's do decimals here. So what if I did like 0.5 and 0.2? You can see what that does is does a horizontal stretch. Okay. All right, then we got the last thing we're going to be looking at are reflections here. So reflections, we are just going to be taking a graph and multiplying by a negative. So we're going to put negative. Now, if it's on the outside here, so if we made this negative, Control C, Control V, negative. Okay, you can see here that just flips over the x-axis. X-axis reflection. Okay, and what if we did it on the inside here? So I did square root of negative x. That is a y-axis reflection. Okay, so these are going to be the general rules that we're going to have to go back and learn, and we're going to take our time. And if that was a lot of information all at once, that's okay. But these are going to be the things we're going to focus on, and we're going to first start just doing one kind of transformation at a time. You know, what we could do here is like I could take a graph here, like square root of x, and I can do like y equals 2 square root of negative x, and then I can do like plus 6. Okay, so you think about what we just did there. We times it by 2, so that stretched it vertically. We multiplied by negative on the inside, so that flipped that over the y, and then we went up 6. So you can see we can have multiple transformations, and it all still stems back from this parent function. So our goal is to first, break down, okay, can we identify the transformation? And then can we work on writing those and doing multiple transformations and going first? Okay, so here we go. How are these functions related to? So let's try to figure out what these are compared to the original, and then we'll verify it on a graph. Okay, so we've got y equals x plus 4, and we're comparing this to the y equals x. So if you think about it, the only thing difference is the plus 4 on the end of the equation. If we go back to our notes here, okay, we look here. Oh, I can't scroll first. Oh, yeah, I can. Go back here. I don't have it written down, but when we add onto a number, it's a vertical shift. So we would say this is shifted up. And we're going to be specific now. We're going to say 4 units. All right. And then this one here, we got -5. So that's, again, just changing the function at the end. All right. So this is a shift down 5 units. All right. Now, just to kind of verify this, let's use Desmos to help us out. And if you want to sketch these graphs. Okay, so let's put our original function here. I'll even make it black. Okay, y equals x. All right, nice diagonal line. So then if we do, I'll change this color to pink. Can I? Oh no, what did I just do there? Change this color to pink. Can I? Okay, red's close enough. If I did y equals x plus 4, okay, so it's the same graph, just I would say split up 4 units. Now, the one thing, if you thought about it, it is also because of this equation, the same graph just moved to the left 4. So this is one of those weird ones, but I would say it's just up 4. And then let's go to another one. Y equals x minus 5. Change it orange to match. It's the same parent function, just shifted down 5. Okay, so let's keep this going here, see if we can identify. Now we got y equals x squared is our parent function here. Okay, so if we look here, how does this change? It looks like we are squaring on the inside. We're adding 4. So that is a shift to the, now remember, it's the opposite on the inside. So this would be to the left 4. And here on the other one here, we can see, okay, minusing, that's going to be a shift to the right 5. All right, we can double check here if you want to sketch on yours. We got y equals x squared is our parent function. All right, we got y equals x plus 4 in parentheses squared. Okay, so same graph, and we can tell that's over to the left 4 units. And if we do the other one, y equals parenthesis x minus 5 squared, same graph, just over to the right. Okay, so now it's like, how do we write these equations? Now that we can do this, how can we go through and use? Okay, so if we think about this here, we got to think about compression. What does that do? So look back at your notes and see, how does the graph change? Our compressions are dilations, and so we're going to be multiplying. Now, if we wanted to stretch it vertically, we're going to multiply by a number bigger than 1. If we want to stretch it horizontally or shrink vertically, we're going to multiply it by a decimal. Okay, so if we want to go through and have a vertical stretch of 4, we're going to take our equation, and we're just going to multiply it by 4. So that'd be y equals 4x squared. All right, and we can double check that here. We have Desmos up, and it's always kind of good to use this. There's a lot of rules going on here, so Desmos is going to be a friend. Okay, same graph, just stretch it up. All right, now a vertical compression of 4 means we're going to shrink it vertically by 4 or stretch it horizontally. And if we're going to, not by 4, but 1/2, and we're going to do y equals 1/2 x squared. So compressions and dilations are actually pretty easy to go through. So 1/2 x squared. Yeah, we can definitely see we stretched that out by 2 or shrunk it down by 1/2. Pretty easy to write. We just multiply the expression by that number. Okay, so we've kind of talked about this before with quadratics way back in chapter 2, and we've used these numbers here. So HK, we always said was the vertex, but H is going to be our horizontal shift. All right, positive shifts it to the left, and minus shifts it to the right. K is our vertical transformation, or vertical shift. Positive shifts it up, negative shifts it down. All right, the endpoint or the turning point, or basically your min or maximum, is at the point HK. That's our vertex. All right, if A is negative, all right, the function is across. Okay, so remember, if A is a negative number, it's going to flip. So, okay, we are going to have a sad face. All right. All right, now if the A is greater than 1, we have a vertical stretch. All right, and then if A is less than 1, we're going to have a vertical compression. All right, if the, okay, I forgot to write this here. It is reflected across the x-axis. Okay, so let's go through here, just kind of more transformation. This time we're going to look specifically at quadratics and other types. Okay, so let's start off with an easy one. Let's just start out with y equals x. If we want to stretch y equals x, actually, let's do x squared here, just because that's what we're working with. All right, is stretched vertically by a factor of 2. Okay, so that means we're going to times it by 2. Then translate it 3 units down. What would be the rule for g of x? What would be the equation? Okay, so if we take our parent function x squared, if we want to factor it or stretch it by 2, we're going to multiply the outside number by 2 and then move it 3 units down. That means we're going to subtract outside of the equation, so minus 3. Okay, next what we're going to identify, okay, if we went from y equals x squared to y equals x minus 3 squared plus 7, we have to look at our changes. All right, if we got minus 3 on the inside, okay, so that is a shift to the right 3. And then if we have the plus 7 on the outside, that is a shift up 7. Just double check that, type it on Desmos, okay? Here we got the original function, y equals x squared. Take the 2 seconds it takes to type it in. X minus 3 squared. Oh, I'm not liking my parentheses. There we go. I guess it takes more than 2 seconds, maybe 5 plus 7. Yep, I would definitely say that's over to the right and up 7. Okay, how does this one go? Okay, if we have an x plus 5 on the inside, okay, plus 5 is a shift left 5, and then a minus 8 on the outside, that is a shift down. Take the second, take your equation that we have here, just double check that, okay? If we did plus 5 on the inside, that's definitely to the left. Minus 8 on the outside, that's definitely down. All right, so absolute value functions, basically the same thing. We did this parent function note in our graph, so we can see here. So an absolute value is a V shape where the vertex is at our HK. So same thing, and we're going to have a positive slope on the right side and a negative slope on the left side. All right, so our vertex here is at HK. So, you can even type this into Desmos. Now, just if you guys didn't know where the absolute value function is, you do have to click functions here, and you should see one if you scroll down called ABS. All right, if it's not there, you can find it. Oh, it's actually right here on our toolbar. Absolute value function of x makes the v. So if we want to, we can go through and say, okay, what's the absolute value of x plus 2 minus 4 on the outside of there? And we can see, okay, we can click on this here and definitely see the vertex is at -2, -4. So remember, our equation is y equals x minus h plus k. All right, so our vertex is at -2, the opposite of the inside and then the outside here. All right, so that's a shift to the left 2 and down 4. All right. Over here, if you want to try this one on your own, okay, what about y equals 3x plus 2? Or, whoa, 3 times the absolute value of x plus 6. I don't know the 2 where I came from. All right, so our h here is the opposite of the inside, so that's definitely going to be -6. All right, and then our k is what's being added on the outside. There's nothing being added on the outside. So this should be at -6, 0. So if we think about it, this would be a shift to the left 6, and then stretch, vertical stretch. Ooh, by 3. All right, so double check that here. Just take a second, type it in. All right, nothing on the outside. Okay, we're going to change that to a +6. And then we're going to put a 3 on the outside. Okay, definitely looks like we took our graph here, moved it just to the left. It didn't move up or down at all. It just went to the left, and now everything is stretched out 3 times as much. All right, we got our square roots. Okay, so remember our square root function is kind of like what we were just looking at. All right, and we're going to use that. So the square root has an endpoint, which is at 0, 0. You know, going back to our notes, maybe if we need to write that here. All right, definitely looks like this. The domain is any x greater than or equal to 0, and the range is any y greater than or equal to 0. All right, we've talked about this before, okay? Our h is the horizontal shift. We have this before. K is our vertical shift. All right, positive goes to the left, negative goes to the right, positive goes up, negative goes down. Okay, our endpoint is at our HK. If A is negative, that is a reflection over the x-axis. We got an A that's bigger than 1. That's a stretch. If it's not, it's a compression. Okay, so let's see if we can figure out what these are just by looking at the equation and then verify that. Okay, if we have a -7 on the inside, that means, okay, subtracting on the inside, that's going to be a shift to the right 7. That's going to be a horizontal. And then the -2, or not -2, +2 on the outside, that is a, can't even spell, that's a shift to the shift down 2. All right. Next, let's look at this. I always like to start on the inside, okay? Because it's kind of easier. Okay, minusing, just like this one here. We got a shift to the right 2. All right. We have a -6, so that is a shift down 6. And then we have this times a half. Okay, so that's a decimal. So that is a vertical compression of 1/2 by 1/2. Okay, so let's just kind of double check the 2 answers that we got. The first one here, we're going to take our equation. All we're going to do is put a -7 on the inside. Definitely shifted it to the right. And we have a +2. Oh, I messed up. +2 shifts it up to. Need more coffee this morning. All right, now the other one here, let's do this. Let's change this. Okay, so we got 1/2. Start back with our original. All right, we'll put a 1/2 here. All right, so that's definitely a compression. It got shorter. All right, we got a -2 on the inside. That moved it to the right. And then a -6 on the outside. That moved it down. Okay, so let's think about this. We're going to read these off and try to make sure we can change the equation. All right, we want a square root is the parent that is shifted to the left 7 and down 1 and reflected across the x-axis. All right, so what we need to do, we're going to take our parent function, y equals radical x. All right, to make it go to the left 7, we add on the inside 7. To make it go down 1, we subtract by 1 on the outside. And then to reflect it over the x-axis, we're going to make it negative on the outside. All right, and so let's just double check that with our answer here. All right, so we'll make it negative on the outside. That flipped it over the x. All right, we got +7 shifts it to the left, and -1 shifts it down. All righty, looks like we did it right. Okay, so now what we're going to do is just kind of wrap up everything. Let's identify these parent functions. So we have to make sure we have our graphs and we kind of know what they look like and what they should be doing each time. Okay, so this one here is a quadratic, the parent function of y equals x squared. All right. This one, absolute value, y equals absolute value of x. Okay, so notice these shapes here. We're going up and down, that is a cubic. Okay, we can worry about the transformations later, but let's just first look at this. Okay, straight diagonal line, let's be y equals x. Skip this one here, we can think about, okay, is that a log or is that an exponential? We're gonna have to do a little bit of work to see if we can figure out this one here. We know this one is y equals square root of x. Okay, so we had a couple different ones here. Remember we had like y equals log x. Okay, it kind of looks like that, but we'd have to flip it around. Let's see if we had some other ones. We had y equals exponential. That's like 3 to the x power or 2 to the x some number. Okay, I'd say definitely looks like that one just flipped around. Do we have any other ones here? Going back to our notes. Okay, no. Cube root, no. Y equals x, no. All right, so I would definitely say that this one is a exponential, which is y equals some number to the x. And what we'd have to do is, what if we made the inside negative? I made that negative x. Okay, definitely starts looking more like, sure, I bet if I did 4. Ooh, 4 to the negative x power. That's still not, and then probably shifted it over a little bit. Make it work, but okay. Good enough. Okay, now what we're going to do is here we're going to look at these and can we get more specific? Can we state the parent function and then the transformations of the graph? Okay, so here we go. Breaking these down. If we got a cube, okay, a parabola, that is the parent function, is y equals x squared. All right, now y equals x squared starts here right at 0, 0. So let's see, we're moving this to the left 3 and then up 4. Okay, so we're going to take our notes here. To go to the left 3, we're going to subtract, or no, not subtract, we're going to add 3 on the inside. And then to go up 4, we add 4 on the outside. Just take the second, okay, plug it into Desmos here. Okay, if we got y equals x plus 3 squared is our guess, plus 4. That looks like what we got. And this is how we can kind of change some things. What if it was on the other side? Okay, well, maybe we do -3. Okay, we can see Desmos is going to be really nice for this section here because you can easily click and change the graphs and it can change the look almost instantaneously. Okay, next one here. We got that sideways parabola. Okay, so the parent function is y equals square root of x. Okay, now that normally starts at 0, 0, but let's see. This is shifting to the right 2 and then down 5. All right, so if we want to go to the right 2, we're going to subtract on the inside. and then go down 5, minus 5. If you guys want to pause this video at any time, try these on your own. You think you get the hang of it? That's good. Okay. This one here, we have our absolute value, okay, because it makes the V shape. All right, so it's going to be y equals absolute value of x. Let's see. Normally the V starts at 0, 0, but this is to the left 1 and then up 4. All right, to go left 1, we add 1 on the inside. And then to go up 4, we add 4 on the outside. Okay, last one here. Let's see. We have a graph that is an x squared, right? We got a parabola. All right, but it's to the right 6, down 2, and then it's flipped as well. All right, so let's just kind of mess around with this one here. To go to the right 2, we would add, or right 6, we would subtract 6 on the inside. To go down 2, we'd minus 2. And then to flip it, we'd multiply by negative on the outside. So let's just kind of double check this one here. I always like, something that's flipping. Let's see if we did minus 6 plus 2. Gotta zoom out a little bit. Okay, definitely over there, but it's on the wrong side. So if we do a negative, okay. Oh, I wrote minus 2, but I've typed in plus 2. There we go. Yep, we'd have to make it negative, have flipped over. Okay, these next problems should be pretty easy here. All right, if we look at this graph, you can kind of do process of elimination here. All right, it's not a V-shaped, it's not a sideways parabola, it's not a quadratic. Okay, definitely got an exponential function here. And we can go through and see. Ready? All right, this one here, definitely we got the V-shape. The only choice for the V-shape would be the absolute value. We can use Desmos. We're going to kind of get through this section pretty quick, so sorry. All right, so now let's go through these. If you want to pause the video at any time, we're going to try to look at the equation and identify all of the changes just by looking at the function. Okay, so we're going to say, okay, is it reflecting over the x, the y, shift left, shift right, shift up, shift down? Is it a vertical stretch or vertical compression? All right, I like to look through first, find the shifts. So this one is a shift to the, I'm just going to write the arrow. All right, we are definitely going to the right 1 and then vertical stretch by 3. All right, next one here. If we add 4, that's the only thing changing here. If we add 4, that goes to the left 4. It's on the inside. Next one, okay, if we add 5 on the outside, it's going to go up 5. So keep in mind the difference here. Plussing on the inside goes horizontal. Plussing on the outside goes vertical. All right, next, let's see. What do we got here? We got this half here. So that is a vertical compression by 1/2. And then the negative on the inside. Okay, so negative on the outside was the x. This is going to be a reflection over the y-axis. All right, next, take care of the inside here. We got -7, so that's going to go to the right 7. And then we got a negative on the outside, so if we're multiplied by negative, that's a reflection. But since it's on the outside, that is on the x-axis. So see the difference between the two. Negative on the inside is the y-axis. Negative on the outside is the x-axis. You can use your notes on the test, so make sure you have those. You know where to look at them. Okay, next one here, number 6. Okay, we got -4 on the outside. Okay, so that's definitely going down 4. All right, we have it being multiplied by 2. So that is a vertical stretch by 2, but then it is also a -2. So -2, and it's on the outside. So that would also be a reflection over the x-axis. three things going on here. So keep in mind, -2, we think of that as one number, but it's technically a negative and a 2. So two different things there. All right, keep this going here. We got a -1. Okay, so that goes to the right one. And then a -3 on the outside. That means it goes down 3. No other numbers or symbols there. Pretty simple there. All right, here we go. Got a +1. So that is going to the left one. And then the negative on the outside, remember negative on the outside reflects. The negative is going to be doing some reflecting, and that's going to be over the x-axis. All right, let's see here. We got that 4/3. Well, let's take care of the +2. +2 is going to shift it up 2. And now 4/3 here, we might think of that here. 4/3 is definitely going to be a vertical. But we have to think 4/3 is 1.333. That's bigger than 1. So that is going to be a stretch. If it was less than 1, and I can't spell stretch at all, but it's bigger than 1, so it's going to stretch it. All right, last one. Man, we got everything going on in here. Let's take care of the easy stuff here. We got +1, so that is going to go to the left 1. We got +5. We're going to go up 5. So left 1 and up 5. All right, the 2/3 here. 2/3 is a vertical compression. All right, it is less than 1. And so it's going to shrink it by 2/3. But then we also have a negative, so it is also going to reflect over the x-axis. Okay. Hopefully, you know, we're kind of seeing these. You practice these on your own. It's getting better. No. All right, last part here. Can we take this stuff here and write this in function notation? So we're just going to, you know, we don't know what the parent function is. We're just going to say f of x. Okay, so if we want to shift it vertically up 3, we would add 3 on the outside. But then if we also want to do a horizontal shift of 2, we would -2 on the inside. Okay, pause the video at any time you want to practice these on your own. Here we go. All right, we're going to reflect it across the x-axis. All right, so we're going to make it negative. Vertical compression of a factor of 1/2. Okay, so we'll make it a -1/2 on the outside. And then vertical shift down. All right, we're going to -6 on the outside. Here. All right, next one, f of x. Just leave it like that. I'll leave some space here if I need to. All right, so take this horizontal shift to the left 7. So, okay, we would add 7 on the inside. Vertical stretch, factor of 3. So stretching is multiplying by 3. Okay, next one. You know what I'm going to do? I'm going to put these f of x's here. Both of these. All right, we're going to reflect it across the x-axis. Okay, all we do is put a negative on the outside. Leave the rest alone. Negative f of x. All right, next. Okay, so much fun. We got a vertical shift down 4. Okay, so we're going to put a -4. Horizontal shift to the left 1. All right, so that'd be -1 on the inside. Vertical compression of a scale factor of 0.6. So we would just multiply by 0.6. Okay, there we go. Hopefully not too bad. We're getting the hang of this here. One more little group, and then we're going to be done with these longer notes. Okay, so we got the type of function here. What is this? We're going to be given y equals x plus 5. We want to have a vertical shift up 3 and then reflect it across the x-axis. That shouldn't be an x plus 5. Just realizing this here. It should just be a y equals x. So we got a straight linear function. All right, so if we're going to shift this up 3, we would do y equals x plus 3, and then reflect it across the x-axis. We would make the x negative. Double check that in the graphing calculator. All right, y equals x squared. Okay, so that's a quadratic. we got a horizontal shift to the left. So that means we would add 4 on the inside, vertical shift down. So we would -3 and have a scale factor stretch of 2 times it by 2 on the outside. All right, next, y equals 2 to the x. Okay, so that's an exponential equation. All right, a horizontal shift to the right. So inside of exponential is actually the exponent here. It'd be x minus 2 on the inside. And then a vertical shift up would be +1 on the outside. All right, ooh, what's this one here? We're going to try to name this. All right, we got y equals x, so that's a linear. All right, let's try to figure out what's going on here. We got the +2, so that means it's going to go up 2 on the outside. And then the negative on the outside is reflected across the x-axis. Right. Let's see, and then if we had to rewrite that, okay, that would just be y equals -x plus 2. All right, next we got a quadratic. All right, if we look at this one here, we got a lot going on. We got it to the right 3, up 1, and then stretch 2, vertical stretch. Okay, and if we're going to rewrite that here, all right, we would take inside, we're going to -3, add 1. So this is almost the exact same as what it has times 2. Last problem here. Let's wrap this up. We got another exponential function. We are adding 1 on the inside here. So that would be to the left 1. -3 would be down 3. Nothing else going on here. So that would be y equals, to go left on the inside. Okay, that'd be x plus 1 on the inside, 2 to the x plus 1 power -3. Okay, I know this was a longer notes, but thanks for watching. If you watched the whole thing all at once, that's great. If not, if you guys watched it little by little, if you have any questions on your IXLs, make sure you ask. But if not, thanks for watching. Have a good one, and I'll see you later.